So now I'm going to go over a few problems to show you how the confidence intervals are constructed and how we can interpret them. The confidence interval is constructed around the sample proportion, and then we reach up and down some margin of error. The margin of error is calculated as some critical z times the standard error, where the standard error utilizes the sample proportion and the sample size in its construction. The critical z is based off of some predetermined confidence level, so the problem has to give you the confidence level in order to construct the confidence intervals. Remember that last time I said each confidence level is associated with a specific critical z's, and so you can use these again in these problems that we'll do today. Again, I highly recommend pausing the video and writing these critical z's down for quicker reference when you're doing homework and exams. In the first problem, we look at the sales of a catalog company that promises to deliver orders that were placed on the internet within 3 days. So they follow up with some of their customers that were randomly selected, and they create a confidence interval based on the proportion of customers whose orders arrived on time. So they found that 81% of their customers had orders that arrived on time, and then the margin of error was 4%. So the 95% confidence interval ranged from 77% to 85%. So we can interpret this as the fact that we are 95% confident that the true proportion of customers whose order arrived on time is somewhere between 77% and 85%. To get a better understanding of this confidence interval, let's look at some ways you could misinterpret it. So the first statement here says between 77 and 85% of all orders arrive on time, and this is an incorrect interpretation of the confidence interval. This is suggesting that the true proportion varies, and we're assuming that the true proportion varies, so this cannot be correct because the true proportion does not vary. The second statement is our true statement, and I'm going to go ahead and mark that so that we can keep track of the correct answer. One can be confident, 95% confident, that the true population percentage of orders placed on the internet arrive within 3 days is between 77% and 85%. That is the correct interpretation. Response 3 says one can be 95% confident that all random samples of customers will show that 81% of orders arrive on time. Again, samples don't vary in this statement, and we know that samples do vary. So that's why this is incorrect, because sometimes we're going to be higher than the true proportion, and sometimes our samples are going to be lower than the true proportion. This statement is saying that all random samples will be 81%, and that's just not true. Answer D is also suggesting that random samples don't vary. At least 95% of them don't vary and create this confidence interval that's exactly 77 to 85%. Now, we constructed our confidence interval based on one sample. Many of the other samples will just create different percentages and different intervals, and so it can't be true that 95% of samples will create the same interval. So again, answer 2 is the correct answer because it's getting at the heart of the matter. We are 95% confident that the true population proportion falls within the interval that we constructed. Let's try one more problem. In this problem, we're looking at how the wording of a question may bias survey responses. So here we have 2 different surveys that ask essentially the same thing, but the wording is slightly different. In the first question, they put the statement of fairness first, whereas in the second reading of the question, they put unfair first. So we want to test to see if the wording of the question impacts people's responses to it. So we surveyed 597 people with the first response, and then we randomly selected another 597 people and surveyed them with the second response. Based on that, our survey says that in the first phrasing, 54% said the death penalty was fairly applied. But with the second phrasing, only 45% said the death penalty was fairly applied. So what we're interested in is determining whether or not the phrasing impacts the survey response. And we can do this by creating a 95% confidence interval. So we're going to do that for the first reading and see whether or not the second reading's proportion falls within that interval. So again, we use our sample proportion as the center point for our interval construction. And then we reach up or down our critical z times our standard error. Now, you will note that I'm creating a 95% confidence interval, and in the past I've just used 2 for this. But to be completely accurate, the correct critical z is actually 1.96. So if you want to be more precise, for a 95% confidence interval, you would use 1.96. When we calculate that out, we get a confidence interval between 50% and 58%. That can be interpreted as a 95% confidence that the true proportion of people who think the death penalty is fairly applied based on the first reading is somewhere between these two values. Now the second phrasing was 45%. What that says is that because the second phrasing's proportion is not in this confidence interval, then it's highly unlikely that the first phrasing's percentage is 45%. So we can conclude that the survey impacts how the participants respond to the phrasings. If you put the words fair first, then more people say that the death penalty is fairly applied. But if you put the word unfair first, then more people say that the death penalty is unfairly applied. You could also construct a confidence interval for this second phrasing, and here I've done that, and I'm going to leave it up to you to actually calculate these numbers, but this is the numbers that I get. And you can see that these confidence intervals don't overlap, again suggesting that the true proportion for the second phrasing is much lower than the true proportion for the first phrasing, suggesting that the way that you word questions highly impacts how people respond to them. In the next video, I will cover the margin of error, which is what we're reaching up and down. We can use the margin of error to determine how many people we need to sample to get a particular range for a given confidence level.